Okay, in this video we're going to look at writing the equation for a hyperbola in standard form. We're going to break this objective up into a couple videos for time purposes. So the good news is a lot of what we're going to do in this objective, in this part of our section, is pretty much the same process that we did for ellipses. But there is going to be one big difference. So while the process is similar, they're not exactly the same, but we're still going to find the vertices and do the absolute value for both sides, much like we did with ellipses. However, because there is a minus sign in the equation for hyperbolas, the absolute value of the y-coordinate that's after the minus sign doesn't get added to the right-hand side. That absolute value gets subtracted. So that's the big difference. When we change the equation for an ellipse that has a plus to a hyperbola, which has a minus, with ellipses, because both those fractions were positive for an ellipse, we added the absolute value of the y-coordinates. But with hyperbolas, the fraction that's negative, that y-coordinate's absolute value gets subtracted from the right-hand side. So that's the big difference. Aside from that, everything else is going to be pretty much the same. So if you're okay with that for, like, let's say ellipses, and to some extent circles as well, then hyperbolas writing in the standard form shouldn't be too bad for you. All right, example 2, write each of the following in standard form. We have example A, negative 9x squared minus 108x, and then plus y squared minus 10y minus 380 equals 0. So let's get the 380 over to the other side by adding it. We get negative 9x squared minus 108x plus y squared minus 10y equals 380. So from here, we found the vertex of negative 9x squared minus 108x, which in this case would be negative 6 and 324. So you might have to zoom out quite a bit to get that vertex. All right. And now with y squared minus 10y, again, I'm going to strongly urge that you, instead of graphing y squared minus 10y, that you graph x squared minus 10x. If you graph x squared minus 10x, you get your vertex as 5, negative 25. If you graph y squared minus 10y, you get your vertex as negative 25 and 5, which means you're going to have to remember to switch them around when writing your equation. So again, it's up to you, but I recommend just graphing x squared minus 10x like in ellipses. All right, so for the x's here, we're going to have x minus negative 6, which is x plus 6 in parentheses squared. And then we're going to bring down this negative 9 in front of it. And with ellipses, it would have just been a positive. With y squared minus 10y, it's going to be y minus 5 in parentheses squared. And there's a 1 in front of the y squared. So, I mean, we could bring it down, but we don't need to include it. So we have the negative 9 times x plus 6 in parentheses squared, and then plus 1 times y minus 5 in parentheses squared. Now we bring down the 380 just like with ellipses. However, with the absolute value of 324 and the absolute value of negative 25, because the x term had the negative in front, the negative 9, that means that the 324, the absolute value of 324, we're going to subtract from our 380 and not add it. So again, the x term had the negative in front of it, which means this y coordinate, when we take its absolute value, we're going to subtract it from our right-hand side, not add it. So when we simplify the right-hand side, we get 81. So we have negative 9 times x plus 6 in parentheses squared plus y minus 5 in parentheses squared equals 81. So we want to get this thing equal to 1, so we're going to divide everything on both sides by 81. And again, it's pretty much like the process for ellipses. And we can reduce negative 9 over 81 as negative 1 over 9. So we have negative x plus 6 in parentheses squared over 9 plus y minus 5 in parentheses squared over 81 equals 1. And while there's absolutely nothing wrong with this equation, I prefer to have my positive term first. But you're more than welcome to, as far as I'm concerned, keep this answer the way it is. But I just make my positive one first because, you know, it's positive. I'm trying to be positive here. So now we have our standard form, and then if we had to find the vertices and foci, we can do that now, much like we did with example 1, once it's written in standard form. All right, part B, we have negative x squared plus 12x plus 4y squared minus 24y minus 144 equals 0. So let's get the 144, negative 144 over there by adding it. And for negative x squared plus 12x, that vertex is at 636. And for 4y squared minus 24y, again, going to graph 4x squared minus 24x, that vertex is at 3, negative 36. So we have x minus 6 in parentheses squared and y minus 3 in parentheses squared. So again, here's our x minus 6 in parentheses squared. Here's our y minus 3 in parentheses squared. And now we'll copy down the coefficients for our squared terms. So for the x, we have a negative 1, so we'll copy that negative in front. And then for the y, we have a 4, so we'll put a 4 in front of the y minus 3 in parentheses squared. Now, again, we have the 144. Because the x squared had the negative, we'll be subtracting the absolute value of 36 from our 144. And the y had the positive, so we'll add the absolute value of negative 36. Well, it turns out that these two are going to just cancel out to 0, so we're going to be left with negative x minus 6 in parentheses squared plus 4 times y minus 3 in parentheses squared equals 144. Then from there, we can divide both sides by 144, and we have 4 over 144. That's going to simplify to 1 over 36. So we have negative x minus 6 in parentheses squared over 144 plus y minus 3 in parentheses squared over 36 equals 1. And again, while there's nothing wrong with the equation the way it is, I like to keep my equation, my first term, positive, so just switch those two around. Also remember, when rewriting an equation, if you graph your equation that you came up with and graph the original problem, if those two graphs are identical, then that means you didn't make any calculation errors, so that should be a good sign. So we'll look at some more examples in the next video, but that's it for this one. Thanks for watching. I'll see you next time.